Hi, students. Today we're going to talk about sedimentary rocks. The rock you're probably standing on, sitting on in your house, is probably made up of sedimentary rocks. So most of Kitsap County, sedimentary glacial till, and it turns out 75% of the Earth's surface is sedimentary rocks. So these are well-known rocks. We see them everywhere, and you will get to know them pretty well too. So the first thing we have to figure out is, well, what the heck's a sediment? So a sediment's going to be anything that's a solid material, can be made up of rock, mineral, the remains of plants and animals. It can be super small like a sand of grain, really, really big like a giant boulder. And we're going to take a look at this right here later. That's a glacial erratic. Okay, so this is just a little aside, since most people think of sediments as sand, which is true, but there's other types of sediments. One kind of sand is made by this fish. This is a parrotfish. It chomps on coral to get the algae inside the coral. It doesn't really want to, it doesn't get any nutrition out of the sand or out of the coral other than eating the algae. So it's got to get rid of the sand, and it literally poops out sand. So those white, beautiful white sandy beaches, those are actually parrotfish poops. And thank goodness for the parrotfish. So if you want to watch this, you can either Google it or you can watch this video on the presentation. So sedimentary rocks, it's a 4-step process. The first one is erosion, then deposition, compaction, and cementation. And I'm going to go over each one of those things with you. So the first thing is erosion. Erosion is a process. It's taking something from here and bringing it over there. And the way we do this with sediments is we use water. We can use wave action. Glaciers do it. Wind does it. There's probably a couple other ways too, but we're just going to stick with those 4. So deposition by water. Here's some wave action. You can see the water's discolored here. That's wave action breaking down the landform here, and also just any runoff, any rain that came off of these little hills and these mountains. It's going to discolor the water with the sediment. Here's a little bit better example. This is the Elwha River up in Port Angeles, and here's the river. And as it hits the ocean or the Strait of Juan de Fuca, it drops all of its sediment. So the river comes down, it picks up little bits of dirt, sand, little rocks, and as it comes down, when it hits that water, it slows it down. It no longer has the momentum to move the sediments on, so it drops it. And you can see right here, here's the river delta. That's what we call the delta. This is all sediments that actually that came up from up above. This has an ocean current, and this current is taking it to Port Angeles. So there you go. That's by water. Wind is, this one's kind of fun. You probably have seen or heard about a sandstorm. They actually call them haboobs. It's a funny name. This, you think mostly it's going to happen in Africa or in China where they have the big deserts. This actually happened in Arizona. This is Phoenix getting hit by a haboob. Massive sandstorm. Lasts about 30 minutes to an hour, and then it's gone. But it drops off a huge amount of sediment. Another place where we get huge sediment movement is right out of Africa. We've got a wind that goes across, and it drops it all in the Amazon. It's good for the Amazon. And if you wanted to watch that in action, it's an excellent NASA video right here. Okay, and how did we get our soil and sediment here in Kitsap County? It came from glaciers. Think of a glacier as a big giant river of ice. And as that river moves by, it literally is strong enough to break apart rocks on the sides. All that black stuff right here, this gray stuff, that is all scraping off the material on the side of the mountain. As these two glaciers form together, you're going to get a nice big black line through your glacier. The glacier carries a whole bunch of sediments. When the glacier eventually melts, you get this really beautiful fjord, like our Hood Canal, really deep. Or sometimes you'll see this. a U-shaped valley. That also, if you're in Seebeck and you look across the water, you'll see this beautiful U-shaped valley. But you can see, where did all that sediment go? Well, it's either going to be dropped off on the sides, or it can be dropped off at the end. Think of a glacier or an ice sheet as pushing, pushing, scraping, scraping like a bulldozer. And then when the glacier retreats, you're just left with all that sediment. This is called a glacial moraine. This is pretty much what Kitsap County is made out of. 10,000 years ago, we had glaciers come on right here, and then they melted and dropped everything. Sometimes they'll drop really, really big rocks. So this is a granite boulder in a big field where there's not a lot of other boulders. It's obvious glacial erratic. That's what we call those. They're really fun to find. We have a bunch here. There's one down at Waterfront Park. There's the one in Paulsbo down at the waterfront. Frog Rock on Bainbridge is one. They're super fun to find. And sometimes you'll have something like this, like, where did this rock come from? It came from a glacier. It was carried down from the north, dropped here. And I say dropped, I mean the glacier melted and deposited it there. Okay, so we're going to move into deposition. And this also is a little bit, well, this is deposition. This is Mount St. Helen. It released a huge amount of ash. When that ash settled, people in eastern Washington got hit with a huge amount of ash. So volcano exploded, the wind carried it, and then deposited it. Some places you can really get feet and feet of ash. So that's the whole idea, that the earth is constantly changing and moving, and material is moving all around. So once the material has moved and it gets deposited, it means it stops moving, and you keep getting layer upon layer upon layer upon layer. That's called compaction. You're depositing those layers, and the weight and pressure starts compacting all this material. You can see here all the different layers of sedimentary rock right here. The last step is cementation. So you can have a whole bunch of layers, but if they're not glued together, they're just going to fall apart, kind of like our soil here. Cementation really happens after erosion brings the material, stacks it up, deposits it, stacks it up, compacts it, and then you need water to help dissolve some minerals. You end up getting this sort of mineral glue that holds all the sediments together. So this is a beautiful piece of sandstone. This is sandstone rock right here in Utah. It's beautiful. And it's actually a pretty fragile rock because you can easily take it apart. It's not glued together all that well. So let's take a look at some examples of sedimentary rock. I don't know why, but this is my favorite. It's called the conglomerate. It's super easy to see that it's sedimentary because it's made up of other rocks. It's huge, big and chunky. This is shale. This is very, very fine particles compacted together. And this is limestone, which actually is a type of sedimentary rock created by what used to be living organisms. Coal is another great example of a sedimentary rock. And if you wanted to know a little bit more about the coal formation, I put a little video in there. All right, so let's just review for a second. How do you get a sedimentary rock? You got to move material from here to over there. You can use water, wind, all sorts of different ways to move material. Deposition means, okay, the material has moved over and now we've dropped it. Compaction is layer upon layer upon layer upon layer upon layer. And then cementation is dissolving those minerals and getting new little crystals forming in there to glue those sediments together. All right, well, there you go. That is our sedimentary rock lesson for today. And thanks for watching. And rock on. Let's